Alright, so today we're looking at how do we describe the end behavior of polynomials. Well, end behavior just tells us where the tails of the graph go as x goes to positive and negative infinity. So as x keeps going on to infinity, what happens to this tail? And as x keeps going on to negative infinity, what happens to this tail? And we represent them with actual arrows, actually. So this would be like a down-up in behavior, which we can represent just like that. Alright, so to determine end behavior, we only need the degree of the polynomial and the leading coefficient. And just as a reminder, the degree of the polynomial is the largest exponent of x, and it would be like right there. The leading coefficient is just the number attached to it. So the very first number I like to look at is the coefficient, because this tells me how the graph will end. If the coefficient is positive, it will always end going up. Whereas if it's negative, it'll always end going down. Then, whenever we look at the degree, if it's even, then these two tails will end going the same direction. Whereas if it's odd, they'll go in opposite directions. And so we can see this in these two examples here. Here we have the leading coefficient is negative, so that tells me that it's going to end going down. And since the degree is odd, that lets me know, okay, then I need to go in the opposite direction. Right, 3x squared. The very first thing, this 3, it doesn't matter that it's even or odd. It just matters that it's positive. That lets me know it ends going up. And then the x squared, since that's even, they both go up. Right? But that's easy whenever you're looking at a graph. What if you're just looking at the polynomial? Let's do some examples. So again, yeah, with the graph, yeah, that's easy, right? This is a down up. But here, let's look at number 2. I only need the degree of the polynomial and the leading coefficient. So this x to the 4th is the biggest degree, so I can just ignore everything else. All right. Now, because this -2, that negative lets me know it's going to end going down, and then this 4 is even, so it'll also start going down. So this is, if you were to graph this, both tails would end going down. All right, in the next example, the degree of the polynomial here is 5. So it's kind of tricky. We've got to ignore these. And this is a positive 1x to the 5th. So the positive lets me know it's going to end going up. And the x to the 5th, since that's an odd number, that lets me know it started down and ended up because it's an odd. All right, but what if it's just not technical enough just to use arrows? Well, it really isn't technical enough, and that's why we have to write these things using function notation. So here we have f of x is equal to x cubed minus 6x plus 1. This is the same function we saw a minute ago that is down, up. Okay? So here's how we describe them. All right, so we say as x goes to negative infinity, f of x goes where? Okay, so these arrows are read as goes to. So as x goes to negative infinity, so as we go more and more left on the x-axis, what's happening to f of x? F of x is going down and down and down all the way to negative infinity. Now as x goes to positive infinity, what's f of x doing? Oh, it's also rising and going to positive infinity. All right, so let's try and write our answers from earlier in function notation. So earlier, whenever we saw y equals negative 2x to the 4th, we had it was down, down. So that means as x went to negative infinity, well, then I look at this left arrow because that would be going left. F of x also went to negative infinity because it went down. And as x went to the right to positive infinity, our function f of x actually went down to negative infinity. And then finally, number 3, this is just the same kind of example as we already saw. As x goes to negative infinity, the function's also decreasing. So f of x also went to negative infinity. And as x grows and grows to the right, f of x also grows to positive infinity. And that's how we describe end behavior. Bye.